Welcome to Master Mathematics in Minutes. Today's topic is about matrix multiplication, and we'll cover a couple examples on how to apply the matrix multiplication method. And we'll conclude the topic with a summary. And finally, be kind and subscribe for more videos. So, how can we perform matrix multiplication? To multiply matrices A and B, where matrix A has order m by n and matrix B has order n by p, we'll apply two steps. So step 1 is where we multiply the row elements of A by the column elements of B. And then the second step is where we sum these together. And the order of the matrix A times B is m by p. So in order to multiply two matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. And the resultant matrix AB will have m, number of rows from the first matrix, and p, number of columns from the second matrix, hence m by p. We'll have a look at this visually. So, we have matrix A with order m by n, and matrix B with order n by p. And because the number of columns in the first matrix is equal to the number of rows in the second matrix, we're able to multiply these two matrices together. And the resultant matrix has m, number of rows for matrix A, and p, number of columns for matrix B. So, we'll consider a 2 by 2 matrix and expand on this knowledge further. Consider the matrix A, which is 2 by 2, and matrix B, which is also 2 by 2. So the number of columns and the number of rows are the same between the first and second matrix. And so we're able to multiply these two matrices. So to do that, we can apply the matrix multiplication method. So we have A times B, and what we've done here is we've copied down matrix A, and we've also copied down matrix B. So step 1 is where we multiply the row elements of the first matrix against the column element of the second matrix. So with A times E, which is that A times E, and with C times F, which is that C times F. And step 2 is where we sum these two, and with the first entry of the combined matrix. So we'll have a look at the second entry. So once again, we'll multiply the row elements by the column elements. So with A times G, that is A times G, and with C times H, and that is at C times H. And step 2 is where we sum these two together, and so we'll put a plus sign. And we'll proceed on to the third entry. Again, we'll multiply the row by the column. So with B times E, which is at B times E, and D times F, which is at D times F, and step 2 is where we sum these. And the final entry, again, we'll multiply the row by the column, with B times G, which is that B times G, and D times H, which is that D times H. And once again, step 2 is where we sum these entries. And so, by populating each of these entries individually, we're able to find the combined matrix of any matrix multiplication. I know there's a lot to take in, but it'll make a lot of sense when we cover a couple of examples. In the first example, we're asked to multiply the following matrices, A and B. And so, the first step is to check the order of the matrix. So, matrix A has order 2 by 2 because we have 2 rows and 2 columns. And matrix B is 2 by 2 as well. And so, the number of columns in the first matrix equals to the number of rows in the second matrix. And so we're able to multiply A and B. And the resultant matrix has the number of rows from the first matrix and number of columns from the second matrix. And so AB is 2 by 2. So matrix A times B is equals to, we'll work on the first entry. We have row multiplied by the column. So with 2 times 8, which is that 2 times 8, 7 times 9, which is that 7 times 9. And step 2 is where we sum these together, so we'll put a plus sign. And so the second entry, we'll apply the same thing, row multiplied by column. So with 2 times 21, which is that 2 times 21, 7 times 5, which is that 7 times 5, and we'll put a plus sign as step 2 to sum those. And we'll cover the final entry. So for example, we have this row, which will then be multiplied by this column. So we have 10 times 21, which is that 10 times 21, and 25 times 5, which is that 25 times 5, and once again, we sum those. And so on. And so by simplifying this matrix, we have 79, 77, 305, and 335. And that is how you complete a matrix multiplication. So the method stays the same regardless of how big these matrices can be. So it could be a 3 by 3, 5 by 5, 10 by 10. You will just need to populate the same method for all of the entries, and you will be able to obtain the matrix multiplication. In a second example, we're asked to multiply the following matrices, A and B. And so firstly, we'll need to determine the order of these matrices to be able to tell whether we could multiply these two matrices together. So firstly, the order of matrix A is 2 by 3 with 2 rows and 3 columns. And the order of matrix B is also 2 rows and 3 columns, so 2 by 3. So the number of columns in matrix A, which is 3, does not equal to the number of rows of matrix B, which is 2. And because of that, we're unable to multiply these matrices. In the third example, we're asked to find the matrix multiplication AB, and we're given these matrices A and B. And firstly, we'll need to check the order of the matrix. So matrix A is 3 rows by 2 columns, 3 rows by 2 columns. Matrix B is 2 rows by 3 columns, 2 rows by 3 columns. And so the number of columns from the first matrix equals the number of rows in the second matrix. And so we're able to multiply these two matrices together. And we have the combined matrix AB. And the number of rows is from the first matrix, 3, and the number of columns is from the second matrix, 3. So AB is 3 by 3. And so we have matrix A multiplied by matrix B. For the first entry, we will apply the first row multiplied by the column. So with 1 by 20, which is that 1 by 20, 15 by 50 is 15 times 50. And step 2 is where we sum these two. And that gives you the first entry. That simplifies to 770. And for the second entry, we'll multiply the row by this column. So with 1 by 40, which is that 1 by 40, and with 15 by 30, which is that 15 by 30, and step 2 is where we sum these, and that simplifies to 490. So you'll apply the same rule to populate all of these entries, and this is the resultant matrix that you will obtain. Say, for example, if we're looking at this entry, we'll take the last row multiplied by the second column, because this is in the last row and the second column. And so you have 92 multiplied by 40, and that's 92 multiplied by 40, and you have 100 multiplied by 30, which is 100 multiplied by 30. And step 2 is where you sum these two together, and that gives you 6,680. In the fourth example, we're asked to find A, B, C. So we're multiplying 3 matrices together. And with matrix A and matrix B from before, It's identical to the previous example. And matrix C is the new matrix here. And so, firstly, we'll need to check the order of these matrices and determine if we're able to multiply these across. So the order of matrix A and B were from before, 3 by 2 and 2 by 3. And we saw from the previous example that the combined matrix A, B has an order of 3 by 3. So we haven't actually introduced anything new. We've just recalled what we've done in the previous example. And matrix C has 3 rows and 1 column. You have 3 rows and 1 column. And so the number of columns in the combined matrix AB is 3. And the number of rows in matrix C is also 3. And so we're able to multiply matrix AB with matrix C. And the resultant matrix ABC has the number of rows from the first matrix, which is 3, and that is 3, and it has the number of columns from the second matrix, which is 1, and that is 1. So the combined matrix ABC is 3 by 1. And so we have A times B times C, and we know A times B is this matrix from before. We saw that there was 770 in the first entry, 490 in the second entry, and we have 6680 for this entry here. So what we've done is we've copied the entry or matrix AB from the previous example, and we'll multiply that by C. And so bringing C in here is where we have 1, 2, and 5 as the entries of matrix C. And we'll copy matrix AB as is from the previous example. And once again, you apply the same method. You multiply the rows by the column and sum these. So we have 770 multiplied by 1, which is that 70 by 1, 490 by 2, which is that 490 by 2, 158 by 5, which is that 158 by 5. And step 2 is where we sum all of these together. And that simplifies to 2,540. And by applying the same method, you're able to populate the entire combined matrix ABC in this case. And so, once again, it has 3 rows and 1 column. So we have 3 rows and 1 column. And that is the resultant matrix A, B, and C. To summarize, we're able to multiply matrices together. So consider the case where we have matrix A of order m by n and matrix B of order n by p. Because the number of columns from the first matrix is the same as the number of rows in the second matrix, we're able to multiply these two matrices together. And the combined matrix AB will have order m by p. And so to multiply these together, we have step 1, where we multiply the row elements of A by the column elements of B. And then step 2 is where we sum these together. And the order of the combined matrix AB is m by p. So consider the case where we have matrices A and B of order 2 by 2 for both, with A times B, with matrix A times matrix B, and we'll multiply the row elements by the column. So with A by E, and with C by F, which is that C by F, and we'll sum these together. And we can populate all the other entries to obtain the combined matrix A, B. Thank you very much for watching. This is Master Mathematics in Minutes.